We got to know this circuit in the last video. This is NAND circuit with the NAND circuit as the base. As a reminder, this is the truth table for this circuit. We will also be working with mathematical symbols today. And as a symbol for the NAND connection we use an angle with a line over it. And now let's look at some circuits with NANDs. First, let's see what happens if we connect both inputs together. As you can see, the entrance is turned around. This is usually referred to as a NOT circuit. We will mark this with a dash in the equations. Now we take our NAND and use a second NAND to reverse the result, as with the NON circuit. As a result, we only get a 1 if both inputs have a 1. Therefore, this circuit is also called an AND circuit. That's why NAND also stands for NOT AND. The symbol for AND is therefore also the angle without the dash. Now we turn the input of both inputs around and connect them to another NAND. As you can see, the result is only 0 if both inputs are 0. This circuit is called an OR, more precisely, an inclusive OR. The equation for this circuit looks like this. As we have already learned, you can make a NOT out of the brackets. We now redefine this equation and use an inverted angle as the symbol for the OR. If we let the output of the OR circuit be followed by another NAND, then we get a NOT OR circuit. The derivation is the same for NAND, i.e. we take the angle of the OR as a symbol and put a line over it. Now let's build a slightly more complex circuit. As you can see, the result is only 1 if there is exactly 1. This circuit is called exclusive OR. As a symbol we take the same symbol as the OR and put a dot above it. Now let's modify the last circuit a little. As you can see, this results in the exact opposite of the last circuit. Therefore this circuit is also called non-exclusive OR. Or even equation, since it only results in 1 if both inputs are the same. The symbol we use here is 3 lines on top of each other. These were the most important basic circuits of logic circuits. We'll go into these in more detail in the next videos. We will also look at how to deal with the corresponding mathematical equations. We will also create replacement circuits and use them as we move forward. But first there is something to program in the next video. We create a script with which we can easily create the scripts for the circuits.